Hi, hello, welcome to Sree Academy. Myself Chandrasekhar. Let us now discuss the subject microcontroller. 8051 microcontroller. 8051 microcontroller. In short, it is MUSI microcontroller. It is an acronym for microcontroller we generally use. Okay, now let us discuss. This is a subject is there in Ecet syllabus for 3 branches, namely that is specially ECE, of course EEE, and instrumentation, IN or AEI, anything, instrumentation. So 3 branches are going to have this subject 8051. Majorly ECE instrumentation fellows are going to get more marks in 8051. Comparatively, EEE fellows are going to get comparatively less marks than these 2 branches. Let us say ECE and IN branches are going to get 10 marks. These EEE people may get 5 marks out of it. Now let us discuss what is the syllabus in this 8051 microcontroller that we have to read and that we have to go through, and how the questions are going to be asked, how we answer, what are the shortcuts to implement, and what is the in-depth knowledge what is there in 8051 that we have to learn. All these things let us see. Now I would like to discuss marks criteria that I told you already. EC are going to get definitely 10 marks. Nowadays they are giving 10 plus 5 to 10 plus 2 marks. I mean from 12 to 15 marks they are varying. This instrumentation fellows definitely they will get 10 marks. More than that also it is possible, plus or minus 2 to 3 marks. Nowadays what is happening in engineering syllabus is, initially they used to give 10 marks only from each subject. Now it is not happening like that. It is not fixed for a subject. For suppose in a year EDC is given 10 marks, network theory also given 10 marks. Okay, where microcontroller is given only 5 marks. But nowadays they are giving 25 marks from communication, 15 marks from EDC, 10 marks, 12 marks from like microcontroller. They are varying the weightage of marks from subject to subject. So we need to approximate that I am saying as 10 marks here, 10 marks here. EEE people, moreover you will get 5. Plus or minus it is possible 2 or 3. Here also plus or minus it is possible. Here also plus or minus it is possible. Plus or minus 2 or 3 marks. Okay. So this is going to be 10% of your total engineering syllabus. So easy subject. If you understand the concepts well and good, whatever I am going to tell you, if you remember those things, you can answer each and everything. Okay. I'll be teaching you in a smoother way. If you understand the topic of digital electronics class, whatever are there, whatever content I given you in digital electronics class, if you remember those concepts, okay, that is enough to do this, to get this 10 marks from this subject. So digital concepts, when you are clear, definitely you will understand, 100% you will understand, and 100% you will get this 10 marks from this subject. When and only when you are going to read that already digital electronics. Let's move further. I would like to discuss what is there in this 8051 syllabus. Okay. Now if you come to the point syllabus, listen to me. If we see the syllabus, majorly this 8051 syllabus, it categorized under basically you can say its architecture. Its architecture means in 8051 microcontroller, whenever we go to market and whenever we going to purchase 8051 microcontroller, what we are going to get is a single IC, simple IC. Okay, that IC, inside that IC, what is there, what all blocks are there, how it is going to perform, that architecture is majorly important. Once the architecture is known to you, okay, and once it is there, for suppose in your home, if you have vessel, that is your source to make what, to make some dishes, like that. Inside the architecture you have the blocks, what are the blocks are there, you come to understand whenever you read this topic. Now once you have this architecture, how they will work, what we have to give and what it will give us, okay, what is the input conditions, what is the output conditions, how we are going to give, how we are going to take. These conditions we are going to say as instruction set. Instruction set. This instruction set may be C language, may be assembly language. So 90% of the content is asked in Ecet is assembly. But nowadays in present world we are not using assembly at all. We are using high-end languages. High-end languages in the sense C language, okay, whatever the high level languages for embedded system like Python, Oracle, all these languages you are going to use. But in basic exam level, they are going to pose questions upon assembly only. Assembly is an intact chip level language. You can understand everything what is happening inside the architecture. You can see visually, you can analyze what is happening, what is going to happen. You can see with assembly only. You cannot imagine what is happening in C language. You cannot see it. Only you can give command, but you cannot see what is happening inside the chip. Here you can see, you can understand, you can visualize the concepts. That's a reason why student must go through the basic step. Basic step is assembly. Once you are clear with assembly, go to high-end language. Then you will understand the concepts dead easily. Okay. So this is the set. Later on, what we are going to see, the third part is, okay. Now this is the architecture, what is there and how to work out it. This is the second topic. And third thing, what extra we can connect to it. For suppose if I am there, this is my human body, then what all is there? Heart and lungs and all those are our parts. How they are going to work? Suppose your lungs are working with the air. Input is air, output is also air, like that. Your heart is working with blood. Input is blood, output is also blood. How it is going, how it is coming, these are parts. Then if your upper limbs, lower limbs are there, what all you can handle outside with your hands and with your legs. What all things, external world things, what all you can connect, what all you can handle. Like that, 8051 architecture inside parts we will see. How they will work, input and output conditions, what is the work done out of it, we can see later on that. If extra things, if we want to connect, how do we connect, what all, మనం connect చేయొచ్చు extra దానికి, connect చేయొచ్చు కూడా చూసేది ఏంటంటే, we call it as interfacing. So total your 8051 syllabus is going to have 3 portions. First is architecture, later on instruction set, this is the interfacing. Now coming to the architecture. In the architecture, what all things are possible in 8051? Let me give a brief idea so that we can see the diagrams. Okay. Now I am giving to you brief idea. Now here, architecture means, in the part of architecture we are going to see, first of all, in 8051 microcontroller chip, if you see a chip is going to be something like this, pin dip IC, dual inline package, like this you are going to get something. Okay. Now inside this IT, what all things are there? Majorly, it is going to have a CPU. What is it? CPU is nothing but central processing unit. Okay. It is definitely going to consist of ALU, arithmetical logical unit, and control unit. Both will be there. Along with that, some memory also there. Memory means definitely you can say 2 types of memories are possible in our digital case. One is going to be RAM, RAM. Another one is going to be ROM, ROM. So memory also there. Okay. What else are extra? Yes, there is timers. There is counters also. Okay. So this is going to be timers and counters. How many timers are available, counters are available, that all things are there. Okay. Oscillators, internal. If a IC have to work upon the clock, so this is the digital IC. If it is going to work with the digital IC, your input must be some clock. That clock is going to be generated by some oscillator, square wave simply. So oscillator will be there, inbuilt oscillator will be there. Okay. Timer along with this oscillator, counting operation. Okay. Next, how to give internal and external connection. We seen this, na? Interfacing means how do we connect? If we want to connect, first of all, anything has to be connected to here or here in the sense, what we have to work. So we need to provide a space where we can connect. Okay, like a port. For suppose a charging jack you are connecting to your phone. So it is provided some space. USB port you are provided. Pen drive you are connecting to CPU. There some port is provided. There you are connecting. Like that, this 8051 also has to provide some space to connect to what? To connect external devices, whatever we talk. External anything, if you want to connect, we have to provide some space. This has to provide. Okay. That is what we call as IO ports, input output ports. Port is nothing but a place. Port is nothing but what? A place where you can connect other. Suppose your mobile phone is there, you are connecting a charger, that is port, charging port. Okay, like that some CPU is there, out of that you are connecting a pen, out of to it you are connecting a pen drive, that is what we call as USB port. universal serial bus, USB port you will be calling as. Okay, like this. Mouse you are connecting, keyboard you are connecting with a port where place hole. Okay, that is what IO ports. How many IO ports are there? How do they will work? What all are there? How many are there? How many we can connect at a time? How many we can connect one after other? Like that. IO ports are how many? Okay. And internal to this, all these are connected with some wires. Where all things are? All things are there within this IC. Okay. If this fellow is one fellow, this is one fellow, this is one fellow, this is one fellow, this is one fellow. Suppose, say this is heart, this is lungs, this is something, some other organs. These all organs are connected, some like veins. In our body, veins are connected. So here, how do they are connected? They are connected with buses, wires. Bus is nothing but collection of wires. Remember, it is nothing but what? Collection of wires or group of wires. Just wires. Okay. Small wires will be there. Tiny. Okay. Very tiny wires will be there. How many how bus operation will goes on one after other, how it will share the bus. Okay. This is all going to be your internal architecture. Okay. Now, if this is going to be architecture, how these things are there, how they will work. Okay. What all things are there? I told you here timers is nothing but not only timers, they will also perform counting operation. You can say counters also. Timers and counters. So these are all the internal fellows. These are going to be some blocks. You can say it's a box. It can give you some operation. Where is this box? This is inside this IC. This is also some box. This is also inside the IC. This is also some box of operation. It is also there in this IC. Okay. So if you bring a single IC, that is 8051 microcontroller, in general you are bringing all these boxes clubly as a entity. As a entity, you are getting into one chip of IC. There you are getting all these things. Okay. How do we work with that? How to work? What to do? How do we program it? How? First of all, their operation. How a CPU will work? What is its operation? Okay. Why we say this 8051 chip as microcontroller? Microcontroller. I would like to teach you first what is the major difference between microprocessor and microcontroller. Microprocessor and microcontroller. We will examine this one first. Difference. What is the difference? What makes the difference out of both ICs? Actually, microprocessor is also going to be a IC. That also a simple IC. This also a simple IC. Then what is the major difference between them? If you want to understand that, you have to see this architecture. I will clear with that. I will tell you. Wait. We will further see that. Instruction set. I am giving a brief idea over that. What is there? What we have to read. Okay. Now let's see this one. What is this instruction set? Whenever we come to instruction set, what all things are instructions are possible? I am writing here. First of all, here instruction set in the sense, majorly in the instruction set, what we are going to see is in the instruction set, data transfer instructions we will see. Data transfer, one place to other. But suppose as I told you, these are many boxes are there. Data is something here, I want to transfer it to here. Something is here, I would like to transfer to here. Here to here or here to here. How do I transfer? Okay, if I having collection of data, many bits are along with me, 30-40 bits are along with me. How many bits I can send at a time? Later on, how many I can say? Okay, like that. What is the limitations of sending? How much it can receive? How much I can send? At a time, how much we can send? Okay, one after other we can how many send? Like that. All the data transfer instructions we are going to see here, one to other. What all the modes are possible? Here to there is possible. Then there to here also possible or not? Like that we will see few limitations because same. Next later on, arithmetical and logical units. Arithmetic and logical type of operations. I would like to do some addition criteria inside the process controller. Is it possible? I would like to some logical AND operation, OR operation, XOR operation, like that. Any logical operation is giving advantage. Is there anything is there like that? We will see. So those operations we can get out of it. How do we get? If you have to get, how do we get? Okay, what are the instructions we use and what criteria? What can be the source? What can be the destination? Okay, ఇప్పుడు మనం ఒక దగ్గర నుంచి ఒక దగ్గరికి లాజికల్ యాడ్ చేయొచ్చు, సేమ్ మళ్ళీ రివర్స్ చేయొచ్చా, ఆ డెస్టినేషన్ నుంచి సోర్స్ కూడా యాడ్ ఆపరేషన్ చేయొచ్చా, ఇట్లాంటి కొన్ని లిమిటేషన్స్ ఏమైనా ఉన్నాయా, ఏమేమి లిమిట్. సింపుల్గా చెప్పాలంటే దీంతో అన్ని లిమిటెడ్ ఆపరేషన్స్ వస్తాయి, కాకపోతే దాంట్లో ఏమేమి ఉన్నాయి, ఏమేమి పాసిబుల్ కావు, ఇవి మనకు తెలిసి ఉంటే నెక్స్ట్ ఇంకొక ఐసీ చదువుకుంటున్నప్పుడు ఎక్స్టెండెడ్గా, ఇప్పుడు మార్కెట్లో రన్ అవుతున్న ఐసీ ఏదైనా ఫర్ సపోజ్ i5 ప్రాసెసర్ ఉంది, i7 ప్రాసెసర్ ఉంది, ఇప్పుడు మీకు దీనిపైన బేసిక్ ఐడియా అన్నీ ఉన్నప్పుడు ఇవన్నీ మరి దీంట్లో ఉన్నాయా లేవా, దీంట్లో ఏమైనా లిమిటేషన్ ఉందా, అన్నీ ఓవర్కమ్ అయినాయా, ఏమేమి అడ్వాంటేజెస్ ఉన్నాయి, ఏమేమి డిసడ్వాంటేజెస్ ఉన్నాయి, ఆల్ థింగ్స్ యూ కెన్ కమ్ అక్రాస్. ఇఫ్ యూ నో బేసిక్, you can apply that basic knowledge onto the high-end chip, that is i7, i9, i12, whatever it may be. I'll give you the brief history. We are not entering into 8051. I'm just giving a brief idea of it, what we are going to read. Chalo. The next programming instructions, program control instructions. Program control instructions. This also there. Okay. So this can be also called as somewhere else branching instructions. Okay. So major sets are this only. Okay. Data transfer, arithmetical and logical, program, controller, program, branching, call and jumps and all those things comes under here. Okay. These are the bit manipulation also possible there. Single bit instructions are there. Bit manipulation instructions. One bit we can manipulate. Manipulation instructions. Bit manipulation instructions also there. So total 4 kind of instructions. I am giving a brief. Total whatever you know, you leave it. Okay, listen to me first. Here you continue. This is enough. Okay, like this you learn. It will be helpful to you. So 4 types are there. This 4 types is quite enough. So your academics, whatever you may learn, 6, 8, 10 types, that, this, all things you leave. All will be falling under to here only. Data transfer. Either that instruction may comes under data transfer or arithmetical logical or else program branching or else bit manipulation. That's all. Only each and every instruction can be, each and everything have to be any criteria. It has to fall out of this 4. It has to fall definitely. ఏ ఇన్స్ట్రక్షన్ తీసుకున్నా సరే ఈ 4 ఏదో ఒక దానికి వచ్చేస్తారు. అలా గుర్తుపెట్టుకోండి. రైట్, లాస్ట్ పాయింట్ ఇంటర్ఫేసింగ్. So as I told you, if you want to connect some extra devices to this microcontroller, what these extra devices are, what they are meant for, what devices we can connect, what all things are possible, what are they. So in interfacing you are going to definitely read majorly 8255 PPI, 8255 PPI, programmable peripheral interface, PPI. Programmable peripheral interface. 8255 you will read what are the advantages, what are the inbuilt criteria, why we have to use, what is that, we will see. Second thing you are going to see is very little you will ask in Ecet, but you need to know something about it. What is there, what all points good in that, what all not good in that. So one is thing here, RTC, real time clock, not Road Transport Corporation. This is real time clock. Okay, this is for timing. Okay. One more thing is ADC 84. Okay, ADC 8080. So this is the ADC and DAC. What we can connect, how do we connect, cut, all those things we will see. And lastly, you have to remember these names only. Inbuilt into that he does not ask, but you need to remember few things like connection. So if you want to connect here, connection pins are there. Those are going to be called as DB9 connector or DB25 connector. Pin numbers, just if you see CPU to monitor, you are going to connect some pin. CPU to monitor, some like RS232 cable, like that you are going to connect. One more thing, printer to CPU also you are going to connect some pins. That is comes under DB9 connector. So in that pin, how many pins are there? DB9 says 9 pins are available. DB25 says 25 pins are available. Simple. Out of 9 pins, what are the pin names, how they will work, what are the sequences goes on in these pins, ఎలా signals pass అవుతాయి అవి ఒకసారి చూడాలి అంతే. Lastly, you will going to see what all devices you can still connect is 8251. It's an interrupt controller, and 8257 DMA. So these are the extra devices. These are the extra devices you can connect to 8051. I mean, more things you can connect in your syllabus, these are there. Okay, so how do you are going to connect these things, what are the limitations possible, what are the advantages possible, what are the instructions. If you are connecting something, you need to handle them. So why all these things are taken into consideration in the sense, if you see, these are not there as a blocks inside this one. So you see, its architecture is this one. In this one, those are not available. 8255 is not there, RTC not there, ADC not there, DB9 not there, 8251 not there. So these are the only architecture. Okay. So if this is only its capability, if you want more than that, okay, I want timing. Only timer counter is there, but real time clock is not there. So I know I need to incorporate RTC here. Is it possible? Inside I cannot put, but outside I can connect and I can use. So if I have to connect this one, at a time what you have to do, if internal all these are there, from here to here I would like to send data. I can use data transfer instructions from instruction set. But now I am connecting an external fellow here. Or suppose think it is 8255. I am connecting here. Okay. If I connect here, this is also going to be now its part, architecture part. When it is becoming its architecture part, if I want to control it, what I have to do? I have to use instruction set. But now comes into picture. So for internal architecture, this instruction set is available. Then external, how do I can apply? Can I apply all instructions? What are there for internal? Can I use all those instructions for this external device also? It is not the possible case. Then how do we do, sir? So how we have to do, sir? All these things only we are going to learn slowly. So when external device comes into picture as a architecture part, then only few instructions out of all these things. From data transfer, only few instructions. If say here 20 instructions are there, we are not going to work with 20 when external is also connected. Only 2 to 3 instructions may be useful. Remaining all may not be useful, may not be valid. Okay, all are valid for internal architecture. But whenever I connect external, all instructions may not valid. This fellow may not able to perform with all those things. Only 2 to 3 may perform. So what instructions are capable, what instructions are not capable to do work with external device, like that we will see. Okay.